Welcome to 11.1, Average Value over an Interval. We know how to find averages of points. If we have 4 points right here, 1, 4, 9, and 16, the average, well, we add them up, 1 plus 4 plus 9 plus 16, that's 30. We divide by how many points we have, which is 4. 30 divided by 4 is 7.5. That's finding average of points. But what if I give you this function, f of x equals x squared, from 0 to 4, and we want to find the average value of every point in this line segment. So this is the line segment of x squared from 0 to 4. We want to see the average of every single point. The average. Well, the average is still going to be the total. And to find the total, we will be using an integral. We're integrating x squared from 0 to 4. We're going to have to divide. Instead of dividing by 4 points, we have to divide by our interval, which in this case is from 0 to 4, which is 1 over divided by 4 minus 0. So the average value would have to be 1 over 4 minus 0 times our total, which is the integral from 0 to 4 of x squared dx, which is 1 over 4, times our integral, which becomes 1/3 x cubed, evaluate at 4 minus evaluate at 0. That's 1/12 times 4 cubed, which is 64 over 12, which is 16 over 3. So it's a little bit more than 5 if we take the average. Okay. Why? Because most of the time the integral is small. So why is this average smaller than the average of the 4 points? As you can see, the line segments here, there are these points that are smaller than the point 1. We have some points on the line that are smaller than 0.4. There are these points in the line segment that are smaller than the point at 9. And finally, there are these points in the line segment that are smaller than the point at 16. So it has to be smaller. Okay, let's look at some more examples. Example 1. G of x is equal to 6x squared minus 4x plus 5. We want to find the average value of g of x from x equals 1 to x equals 7. So that's going to be 1 over our interval, which is 1 over 7 minus 1, times our total, which is the integral from 1 to 7 of our function, 6x squared minus 4x plus 5. So that's going to be 1 over 6. 6 is our interval. Times, after we integrate, we get 2x cubed minus 2x squared plus 5x. Evaluate it at 7 minus evaluate at 1. We plug in the numbers, do the arithmetic, and you get 103. So really, it's just find the total with our integral, divide by our interval. Okay. Example 2. This is from the AP test. Let f be the function defined by, here's a piecewise function, from 0 to 3, f of x is equal to the square root of x plus 1. From 3 to 5, f of x is equal to 5 minus x. We want to find the average value of f of x on the closed interval 0 to 5. Okay. So once again, our average value is going to be 1 over our interval, which is 5 minus 0, times our total. So it's going to be 1 over 5. Well, our total, we're going to integrate from 0 to 3 with our first function, square root of x plus 1, dx, plus we're going to integrate the second function from 3 to 5, the second piece, of 5 minus x dx. Okay. So that's 1 over 5. Let's integrate. The square root of x plus 1 is the same as x plus 1 raised to the 1/2 power. So we can use u substitution for this one. So let u equals x plus 1, then du equals dx. So this really just becomes, so the integral of x plus 1 just becomes the integral of u, the integral of u to the 1/2 power. Okay. 1/2 plus 1 is 3/2. So it's going to be 2/3 times u to the 3/2 power. Except that we can replace the u with the x plus 1. Back to x. Okay. And we want that evaluated at 3 minus evaluated at 0. Okay. Plus the integral of the second part, the integral of 5 minus x, that's going to be 5x minus 1/2 x squared. We're going to evaluate this from 3 to 5. Okay. That's 1/5 times 2/3 times 4 to the 3/2 power minus 0. Sorry, not minus 0. Minus 2/3 times 1 to the 3/2 power. Plus, we have 5 times 5 minus 1/2 times 25 minus 5 times 3, and then 2 minuses become a plus 1/2 times 9. Okay. And that gives us 1/5 of 4 to the 3/2 power. Well, the square root of 4 is 2, cubed is 8, so it's really times 2/3 is 16 over 3 minus 2 over 3. Okay. Plus 25 minus 12.5 minus 15 plus 4.5. Okay. So let's finish the arithmetic. So this gives us 1/5 times 4/3 plus 25 minus 15 is 10. 10 minus 8 is 2. Okay. 4/3 plus 2 is 10/3. 10/3 divided by 5 is 2/3. So the average value of this function from 0 to 5 is 2/3. Okay. Sorry, I made a mistake. It's not 4/3, it's 14/3 because it's 16 minus 2. 14/3 plus 2 is 20/3. 20/3 divided by 5 is 4/3. So the average value should be 4/3. Okay. In your notes, you can see the calculations clearly right here. Okay. Example 3, another AP question. Concert tickets went on sale at noon and were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differential function L for 0 is less than or equal to t is less than or equal to 9. Values of L of t at various times t are shown in the table above. In the table, we're given for t equals 0, 1, 3, 4, 7, 8, 9. We're given the number of people, L of t, at those times. A. Use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30, which is t equals 5.5. Show the computations. Indicate units. So this is a review of average rate of change. The average rate of change we can estimate We want t equals 5.5, which is the middle of 4 and 7. So we can use L of 7 minus L of 4. Remember, average rate of change is like finding slope. Divided by 7 minus 4, which gives us 150 minus 126. Let's divide by 3. 24 divided by 3 is 8. Our unit, well, for our unit, we have L of 7 is 150 people. 126 is also people. And then T is in hours. So it's going to be people per hour. And that makes sense. Yes, how many people are entering every, how many people are buying tickets every hour. B is what we learned in this lesson. B, use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours that the tickets were on sale. So, we're given t equals 0, t equals 1, t equals 3, and t equals 4. So we're given these and then we're given the number of people at those times. So do a trapezoidal sum. We're going to have 3 intervals that are not equal. We have 0 to 1, 1 to 3, and 3 to 4. Okay. And we know that, again, average is going to be the total divided by the interval, which is total divided by 4 minus 0, which is the total divided by 4. We want to estimate the total using the trapezoidal sum. So the total is about our trapezoidal sum. First, we have our interval, which is from 0 to 1. So that's 1. Times, we have the number of people. We want to use the trapezoidal sum. So we want the average of the number of people at 0 plus the number of people at 1. And we want the average, so we have to divide by 2, since that's an average. These 2 points. This gives us the area of the first interval. Next, second interval. This time we're going from 1 to 3. So it's going to be 3 minus 1 times, we want L of 3 plus L of 1. Let's use L of 1 plus L of 3 is the same thing. Again, divide by 2 because we're on the average. Okay. That gives us the area, the estimate for the area of the trapezoid for the second interval. Finally, we have our third trapezoid, the trapezoid from 3 to 4. And that's going to be 4 minus 3 times the average of L3 and L4. So L3 plus L4 divided by 2. Okay. And that's going to give us 1 times, we have 120 plus 156 divided by 2 plus 2 times 156 plus 176 divided by 2 plus 1 times 176 plus 126 divided by 2. Okay. This gives us 276 divided by 2 plus 156 plus 176. That's 242. 242 times 2 divided by 2 is just 242. Plus 176 plus 126 is 302 divided by 2. Okay. Yeah. Let's see. Sorry, for the second one, 156 plus 176 is not 242, it's 342. There you go. That gives us 138 plus 342 plus 156. Okay. Now let's just use a calculator for this part. And Google gives us 636. And then the average has to be 636 divided by 4. Okay, we can use a calculator for that, which gives us 159. So that's the estimate for the average number of people waiting in line. Now there's a lot of arithmetic here, so I probably made a calculation mistake. On the A/B test, you can use a calculator for this, so it's a good idea to check our calculations. So let's do that. The first term is 138. I got it right. The next term, 2 times 156 plus 1 is 332, not 342. The last term, the average of 176 and 126 is 151. Okay. So that's 151. So let's correct our mistakes. So we're getting 631. So it's really 631 divided by 4. So if we do that, we get about 157.75 people.